Hey everyone, today we are solving Pandora from HackTheBox, an easy way to Linux machine. In addition to the video, I've also done a Gitbook entry, so we can go ahead and look at all the commands and all the details as you go along. This was requested by someone, so I thought I'm going to include it for now on my videos if I get time and if I'm able to. Cool, let's get on with the recon. Link to the Gitbook will be in the description. So the first stage of recon is service enumeration and determining what's actually on the machine, okay? So in this case, we want to basically enumerate what ports are on the machine. In this case, I've run a tool called RustScan, which is a wraparound Nmap. And Nmap is effectively a port scanner, and it allows us to enumerate what ports and services are on a machine. And we can kind of go from there. That is initially what we want to look for, and that's how we kind of get a start on the box. So I've run two scans here. We have a TCP port scan and a UDP port scan. Basically, it's important to do both because TCP and UDP ports, they tend to be quite different. Certain services will sit on UDP, others will sit on TCP, so it's very important we cover it at all regards. The top one is the TCP scan, and the bottom one is the UDP scan. For those of you watching videos on the daily, my TCP scan is very generic, simply just does a default script check and enumerate versions and outputs it to a file. The UDP scan is very similar, except we have this flag here to say do UDP versions, making the scan quicker and more intense, basically. But there's not much else other than that. The way I like to do it is I like to start with the TCP ports and then go down. We can see here we have two ports open for TCP, 22 and 80, so that will be SSH and HTTP or a web server. We can go ahead and scroll down and look into this more detail. Yep, as I said before, 22 for SSH. I tend to just ignore SSH in most cases and use it as the last port of call, but we have at 80, so we'll go and look at that. We have 80 here, 80 for HTTP. Doesn't seem to be much on here. That's okay. We'll go ahead and run some enumeration tools. In this case, we're going to go ahead and run GoBuster. GoBuster will effectively enumerate what files and resources are on the box by brute forcing file names and directories and that kind of thing. It will just give us a rough idea as to what's on the box. It's also worth mentioning that sometimes when you do these enumeration tools, you get a bunch of output because basically the box or the web server replies yes to all requests made, and sometimes it can get quite messy. So here we have like a bunch of subdomains here, which I'm just saying yes to. Here we have another command here, vhost. This is for subdomains. Effectively, we'll just check if there are any subdomains on the box that we can access. It's quite messy. I'm going to go ahead and leave that to run. I'm then going to go ahead and run Nikto. Nikto is a web application port server scanner. Basically, it will just enumerate vulnerabilities and anything on the box. I tend to run it just as a case of being thorough, but sometimes it finds stuff, sometimes it doesn't. It's just really a case of just covering all bases. Cool. Let's go ahead and check out the rest. So, web server here. We want to actually go to the web server directly. We'll go ahead and hit enter here. And for some reason Google is intercepting me, so we'll go ahead and add in HTTP. Cool. And this is web server. Let's go ahead and enumerate it and analyze what's going on. Whenever I get a web app like this, I tend to just poke around and just try and see what's on there. Seems to be like a very basic HTML page. No worries. We'll go ahead and click some stuff. Doesn't appear to be much on here. Do any of these buttons do anything? Doesn't appear that is the case. Okay, no worries. We'll go into recon. We'll go into our web stuff here and just check what's coming out. Okay, we're getting a bunch of output from subdomains of 400s. We can ignore that since it's just a basically noise at this point. It doesn't actually mean anything. We have HTML files. That seems to be it. Just a single HTML. Okay, that's fine. So we'll go ahead and just leave that running for now. Maybe something else will come up later. Let's go ahead and look at our recon. Okay, so we've pretty much exhausted our web app enumeration in terms of like looking at the web app briefly, and that's all that's really running. Let's go ahead and look at the UDP stuff. Now, often when you look at UDP stuff, you tend to not find much. Often there isn't much really running on UDP. But in this case, we have a bunch of closed ports, but then we have an open SNMP port. Mixing up my ports there. SNMP is Simple Network Management Protocol, and effectively what this allows you to do is, if you have a public access to the SNMP, you can often just read what's going on the system. The data will vary, but in often cases it will show you like what processes are running and just random bits really that are just being disclosed publicly on the box. If we have a private access, we can sometimes write to SNMP. That is out of the scope of this video, but maybe when I find a box which actually has a private key enabled in there, a private community string, then maybe I will include it. Let's go ahead and now look into SNMP. So the first thing we want to go ahead and do So we want to go ahead and effectively find out what strings are allowed. So this enum scan here will simply run a UDP scan with this script. And this script will effectively just enumerate what community strings are accepted on the SNMP port. And then we here to specify UDP port 161. And we go ahead and hit enter. That will take a few seconds, hopefully it will tell us. Okay, excellent. Here we have a SNMP brute public valid credentials. What this means basically is that Nmap has gone ahead and brute forced a bunch of possible community strings like public, private, hello, crest, I don't know, random strings basically, and has determined if it exists or not. In this case, it's found public, so we can go ahead off that. Sweet. So where do we go from here? So we want to go ahead and effectively now walk across SNMP. And when I say walk, basically I say that in the sense of because there's a tool called SNMP walk. So if we go ahead and now run this command here, go ahead and just remove this. What we're saying here is we want to go ahead and talk to SNMP. We want to go ahead and use version 2c, and we want to go ahead and use the community string of public. Where do we get public from? From the output of here. Make sense? Hopefully it does. Cool. Go ahead and hit enter. And that's going to go ahead and pull out a bunch of information. And that's just kind of a lot. So what I'm going to go ahead and do, I'm going to go ahead and just pipe this into T, and we'll go ahead and call it SNMP out. In addition to that, I'm going to go ahead and also type in code here. So we can go ahead and actually look at the output as it comes through. Go ahead and just close this one in the background. Cool. We can go ahead and just read it as it comes through. And we can almost kind of like grep and all that kind of thing. There's lots of output though, it gets constantly getting written to, as you can see it's getting written to. There's lots of stuff we don't really care about, like we have this integer here, for example. So when this finishes, I'm going to go ahead and grep away some stuff really. We'll know when this finishes because we'll get a prompt. But while it's running, we'll go ahead and just view what's going on. Yeah, lots of just crap, really. The reason I write this to a file is so I don't have to run it multiple times, and I can basically go ahead and just pull down everything I need whenever I want it. And it's also helpful having it in code as well, so I can, grep the bits and pieces. We'll go ahead and minimize this for the moment and decide to finish. I'll let it finish, and we can go ahead and cat it, so SNMP out, and we get a bunch of output, really. Okay, cool. So we can go ahead and now grep away from stuff we don't want. So if we look into our SNMP out here, we have integer. So I'm going to go ahead and just copy this here, the integer, and go ahead and get rid of all that. We'll go ahead and do this. Like so. If we go ahead and now pipe this into WC, before we go ahead and run that, so WC will basically give us a line count. We have 3,000 lines, okay. We do this here, and then we do this now. We now have 1,700 lines, so far less lines. Okay, cool. Yep, then we want to go ahead and do the same, so we'll go ahead and just basically type on another grep, and then type in we don't want a string. Or maybe we do. So in this case, actually, do you want to maintain that sum? So we'll go ahead and just kind of go through, see what else there is. So we have string, and OID stuff, and just kind of go through is to find out what things we don't want. We don't really care about OID. We can go ahead and get rid of OIDs. Cool. And that has now reduced our list to be a few hundred lines less. This should be enough to work with. We'll go ahead and just more it now. We'll kind of go from the top. Okay, cool. So I want to go ahead and just exit out here. We'll go ahead and now view. So here we have a few bits for you. So we have a string Daniel, string Pandora, string Mississippi. We'll go ahead and just hold enter a bunch and kind of just go through. Okay, we don't like counter, but I'll leave it in there for now. It's okay. A bunch of information we don't really care about. Counter is kind of annoying actually. I'm going to go ahead and actually just remove counter since I don't think it's very helpful and it's getting in the way. Grep, -b, counter. Cool. Go ahead and now more it. And we should have far less output. Oh, apparently counter's still in there. That's because I didn't set a case insensitive flag. Okay, cool. Let's go ahead now. Fine. Go ahead and hit enter and just kind of go through. An easy way potentially would be to just grep the string, but we may get the information in a different kind of data type. So it's important to not get rid of any information we may actually want. When you go ahead and hit space a bunch of times to get through this. Okay, cool. And then we go ahead and scroll down. So this looks to me like we're looking at like basically the Unix, like basically the PSOX equivalent, and just looking at like the Unix information, what's running, files, that kind of thing. see here, just bits and pieces really, watchdog and just random bits. We'll go ahead and spam enter a bunch more, kind of just like really scan what's going through. All this information is kind of not helpful right now, but if we go ahead and keep scrolling through, maybe we'll find what we're after. And all the time you will tend to have to just go through logs and stuff, but that's just part of the job really. You know, it's your job to make your life as easy as possible, but of course make sure you're not removing anything that is important. Here we have a bit more things in here, nothing too interesting though. Go ahead and press enter some more. It's cases like if I knew to get rid of this might have made things a bit smaller, but again, it's probably quicker to just carry on through at this point. Cool, go ahead and hit enter. Here we're seeing some stuff here, like we're seeing like what's being ran, so this looks more like PSOX output I was referring to a second ago. But if you look carefully here, we have a -c sleep, bin bash, run some host check, and then a username and a password. Well, what's that on about? Well, maybe we can use these credentials. Let's go ahead and just copy this. I'm going to go ahead and mousepad. Go ahead and paste this in here. Let's go ahead and try and use SSH, since we only really have access to that. SSH Daniel at $box. Enter. Hit paste. Enter. And boom, we're in as Daniel. Sweet. So now we have the SSH checklist. Let's go ahead and look at what our account can do. So we have a named user account, so we'll go ahead and try sudo-l. We'll go ahead and paste password. Okay, we don't have access to sudo. Now, part of the ProRESC we could actually perform right now and get root in a quite short amount of time. However, I'm not going to do that. I'm going to go ahead and do the, I imagine, the expected solution. As it turns out, there's a skip to go, and therefore we can get root in like a few minutes. Or there's the getting another user account, compromising some bits and pieces, and then getting root that way. We'll go ahead and do the long way, but just as a teaser for the root. Effectively, we did the sudo, that didn't work, so the next best thing is a SUID review. So we go ahead and run this command here, and this will give us a list of all the SUIDs. Now, just as a little exercise to the audience, if you get this far and you run this command, try and see how you can ProRESC given this information. And hey, if you can pwn the box without doing any of the long steps, then more power to you. But we'll come back to that later. Okay, so let's go ahead and now enumerate the box a little bit more, ignoring the fact that we know the ProRESC. I like to work off a what I know approach. So what do I already know? Well, I know externally speaking there was a web app and there was SSH. We've used the SSH, but we didn't find much on the web app. I want to go ahead and enumerate the back end of this web app, basically, okay? So we're going to go into cd var www, okay? Go ahead and hit ls, and we have a HTML and a Pandora folder. Now that tells me there's probably two web apps. My guess is a HTML one is this one, because it's a very basic HTML page that doesn't have anything really on it. It's just a very standard HTML page. And Pandora is probably something else. Honestly, who knows? That's why we need to enumerate. We'll go ahead and ls into HTML. And yep, cool, we have an XML. We'll go ahead and grep this, and we'll go ahead and grep the word play. Now, why the word play? Well, that's because inside this web page we have this bit of text here, play, and unless this is generated via, say, some JavaScript, like dynamically where the word play doesn't appear in the entire string, it should appear in the HTML. We'll go ahead and hit enter, and yep, we get is play part of Pandora, play, yes, play, thanks to Panda, all that kind of thing. We'll go ahead and just grab this, like so. We'll go ahead and do a Control F and V. I guess it isn't quite formatting correctly, but maybe we can find yes play somewhere. Maybe not, maybe it's just hidden. It's fine. The point is we're on the play page, we can ignore it for the moment. Okay, so we have assets. We'll go ahead and just ls into the assets, because you never know, maybe there's something in there. Probably not, though. I'm using cats, not ls. Yeah, images, JS, SCCS. There's not really much in here. Okay, cool. Let's go ahead and look into the other one. So we'll go ahead and look into Pandora. Okay, we have a Pandora console, interesting, and we have an index.html. We'll go ahead and just cat the index.html just to see what it looks like. Okay, we're getting just a basic bit of HTML, which redirects us to the Pandora console. We can go ahead and then cat into the Pandora console. We'll go ahead and change this to ls. Like so, hit enter, and there's a bunch of stuff in here. So this could either be a handcrafted web app by the creator of the box, or it could be a third-party application service kind of thing, but we won't know until we really have a look. So I'm curious, okay, so this web app is being hosted. How do we get to it? Okay, let's go ahead and look into basically the Apache configuration. So we'll go ahead into cat, var, no, not var, etc, Apache, I think it's called Apache 2, yep, and I think it's sites available, yep, and then go into, see pandora.conf, and here we have a server name, pandora.panda.htb. Okay, interesting. So we actually do have a web server running in this way. We can go ahead and obviously look at the other one too, which would be probably the 00 default one, which would be the standard web server of just running on AT. We can go ahead and hit say kill. Also, before I mention here, we have the var www Pandora. This one here is var www HTML. That's kind of how it works. Okay, cool. We'll go ahead and then kill our local host just to see which host responds to us. Okay, so killing locally, we get to this host. Interesting. So we'll go ahead and actually just look at our Etsy host, because maybe there's a line here. Okay, we have localhost or local domain and pandora.htb and pandora.pandora.htb, and they all point locally, effectively. I want to go ahead and effectively enumerate this box externally. So again, as an additional way to learn, I'm going to go ahead and set up an SSH tunnel. Very simple. In this case, it will simply just let us make a port forward connection from our internal machine to the web server. So if I go ahead and run this command here, basically what it will do is it will forward any connection on the local host on port 80 via the SSH tunnel to the internal server within the Daniel machine. If I go ahead and hit enter, I'll go ahead and paste a password, it will make more sense. So before I hit enter, or maybe it has already hit enter for me, I'm not sure. Yeah, it hasn't. We'll go ahead and kill 127.0.0.1, right? I'm going to get failure, okay? I'm going to go ahead and just paste the password properly this time. I think I maybe broke something, did I? Is it Hotel Babylon 23? What was 123? Not sure. Okay, that should work. Okay, so that has now made the tunnel. See here, right? So we'll go ahead and hit enter here again, and this time we're going to get the same thing we got when we were local, when we had the kill before, like so. Okay, like this. That is because basically what we're doing is we're sending this request to our local host on port 80. It's then forwarding it via the SSH channel, which is then forwarding it to this internal host, Pandora. Because here we have a Pandora console. Same thing applies in our browser too. We now go to 127.0.0.1. We now get a redirect to Pandora console. Sweet. Okay, so go ahead and just remove this find bar at the bottom. So we have a Pandora FMS. We can see it's Pandora FMS by the title here. Go ahead into the view page source, and there's a bunch going on. So now we have access to the internal, as in the files, and we have access to the external, as in the web app right now. So we have access to both apps, which is very helpful. Okay, cool. Now we see here we have what looks like a version of. I'm going to go ahead and Google that. Go ahead and hit enter. Cool. Looks like we're having a Pandora FMS Authenticator remote code execution. Cool. Let's go ahead and take a look at it. Seems interesting enough. Seems to be invoking some command injection vulnerability. Cool. Now, I never got around to trying this one, since when I did the box, this wasn't indexed on Google. So I did it using, I think it was this way, originally. I don't know, I just never saw that original post, so I kind of just missed it, and I did via the SQL injection way. So, because I think this is possibly more learning, I'm going to go ahead and show this way. Also, this page is great because it talks about all the technical implementation. But simply, in this case, what we're doing is we send the session ID parameter. So, like, session ID equals, XYZ, whatever, equals AAA, to this endpoint chart generator, and that gives us an unauthenticated SQL injection. We can go ahead and test that now. We'll go ahead and just go to the page here. We'll go ahead and then append the include on there, like so. Go ahead and enter, and we get an error. That's okay. Let's go ahead and just check that my URL is correct. Cool. Go ahead and then maybe try session ID equals X. Okay, that hasn't worked, but maybe it's just because we're getting the error, but maybe we actually can still we actually still can invert that command. So basically, we're getting access not granted, but the session ID is actually being processed by the backend. So it's actually checking our session ID, and then it's saying, oh, the session ID you gave isn't valid, doesn't work. So we're getting an error saying, basically, you're not allowed in. But however, we can actually, of course, use like SQL injection to then pull data from the backend database, even though we don't have access to actually log in. I'll go ahead and use SQL map to go ahead and do that. I'm going to go ahead and open a new tab, SQL map. I'm going to go ahead and just close this out of the way. SQL map. Go ahead and hit enter. I'm going to go ahead and make this a star here, so it tells us SQL map. That's where the injection point is. We'll go ahead and hit enter like this. Go ahead and enter. See what happens. Okay, cool. Yes, custom injection marker. Hit yes. All this stuff is annoying. I'm going to go ahead and just remove this, type in --patch. Basically, this will just use the SQL map default options. Go ahead and enter. It's going to go ahead and do its thing. And this will basically tell us if it's SQL injectable. A nice way of just determining roughly if it's actually going to work, because yes, we can do this manually, but on a time box assessment, it's quite important to obviously be quick and obviously try and know what you're doing. In this case, we seem to be getting something, it's pulling down something, so it seems to be working, and there we go, yes, we do have indeed injection. This is the command it's using here, so we can actually go ahead and just take this, we can do a time-based or error-based. I'm going to go ahead and use the error-based one just to see how it looks. I'll go ahead and paste this into here, like so. I think I actually missed a bit there, like this. And I guess that gives us an error. Let's see how SQL actually process that. Did I get it all? No, I think I actually just duplicated this. Okay, yeah, I did. We'll go ahead and remove the extra hyphen. So see here, we got an SQL error, basically saying a duplicate entry. What it basically means is we can, well, actually, I guess in this case, it's just printing out the error that we're providing. It's giving us an SQL error. It's not really that helpful. Obviously, we have the time-based one too, but we know it's SQL injectable. Now, we have a few options here. We could say do an SQL shell. Let's go ahead and try that now. So we can use OS shell, and this sometimes works, it sometimes doesn't work. Basically, what it allows us to do is we'll maybe be able to get a reverse shell via SQL injection. We're going to go ahead and use number 4 since PHP. That hasn't worked, but that's okay, because maybe it needs a little bit of messing around with, but that's fine, because actually there's a version which is made actually specifically for this vulnerability. I'll go ahead and just pull in the link here. And when I say vulnerability, I mean like literally this Pandora FMS client has an instant RC effectively, which will just give us a much nicer experience. The code is here. I had a read through it. It's not too complicated, but I think it's just a case of really just, so if we look here from the top, effectively what it's doing is it's getting us an administrator account. So really we're grabbing the admin account. So we're basically grabbing the admin session, logging in as the admin, so session cookie admin. And then we're then just using that access to then upload a file, which I think is here. Yep, look, so we're just basically making a request to the file manager. I mean, that is in the referrer, but it's basically what we're aiming at. We then upload like a reverse shell or whatever, and then that then stores it here. And then we then just basically reference that file name with the command we provide, and then it should work. Let's go ahead and download this. So yeah, effectively all we're doing really is just getting the administrator session, which actually you can see is probably just going to be, let's go ahead and do like --dump. You'll see, go ahead and batch it. You'll go ahead and actually see that we can go ahead and pull it down ourselves, like so. So it's going to go ahead and just obviously just get all the information really. These are all the tables, and it go ahead and just pull out basically the session. We can then use that session to then obviously upload a shell, and obviously then get RC. But that's going to take a bit of time, so we'll go ahead and just obviously use the commands we have available. We'll go ahead and we'll get the tool we want. I copied that, hit enter. We'll go ahead and do Python 3. Let's go home, and then localhost. We'll go ahead and enter, and it's sent in the payload. If you want to control, we'll go who am I. And we are Matt. Now, like I say, this step, the whole compromisation of the Pandora console isn't really required. We actually can bypass the whole thing by just doing the SUID priv escalation. But this is a nice box to demonstrate using the tooling and not really having to do much work yourself and using it, kind of like just relying on tooling. There are many cases where you have to do the manual stuff on harder boxes. And when you do those boxes, obviously you kind of force it that way, but we have nice tooling. We're going to go ahead and leverage them. Always good. As long as we understand what's going on under the hood, that's all that really matters, you know. SQL injection, dump the session key, use the session token to then upload a file. File is then a RC file, like a web shell, something like that, like here, for example. And we can go ahead and obviously off the back of that and then run commands, and we can then maybe get a reverse shell. So you can see here we actually have access to run commands. So here we've ran who am I, which has given us Matt. We can then do like say, I don't know, ls, which will probably give us a current directory, and indeed it does. So I'm not a massive fan of web shells. I find them, they're okay, but like there's no like session persistence, like there's no interactivity. So I want to go ahead and get a proper reverse shell. So we'll go ahead and do that now. So there are a few steps we could use to get this. So we could simply just like do so, like if I go ahead and type in shells here, which is a tool I made, all it does really is just set up a netcat listener, which I'll show the code in a second, and it basically gives us one of these commands. We can go ahead and say run this now, see how it works, go ahead and hit enter. And unfortunately it doesn't work, probably due to some encoding issues, who knows honestly, it doesn't really work very well though. That's okay. The command it runs is, if we do cat $ which shells, basically it's just running rlwrap, that's tar, and then the command of netcat and lvp, and then the port. Basically netcat listens for a connection, and then this here upgrades our shell to be a better shell. So the main superstar here is netcat and lvp, since that's actually the listener. Cool. And then here it just prints out a bunch of stuff. Really super simple, just helps me speeds up my performance. Cool. Go ahead and run this again. So I'm going to go ahead and actually take this command here and put it into a file, because that way we can a little bit cleaner. I'm going to go ahead and open up a second terminal here. We'll go ahead and then do say nano shell. I don't like to give it a extension because sometimes, you know, the dots and periods can mess things up. I use just shell since it doesn't actually matter what it's called. It could be called s for all I care, or it could be index.html, it doesn't really matter, but yeah, shell is okay for now. So we have our shell. And I'm going to use a tool called lweb, which will basically just print out wget plus http plus my IP plus 9000, which is a port we're listening on, plus the file name, and then set up a Python listener. Python listener is like this, Python -m simple HTTP server. Don't know if that will work, maybe not. Yeah, we're going to obviously fix that there. Server, like that. So yeah, anyway, we'll run that. We'll go ahead and listen, and then we can go ahead and obviously run this here. So we'll go ahead and wget it. I'm going to go ahead and change wget to be curl, because I would actually prefer to just see that it's actually working. We'll go ahead and hit curl, and we can see the request was made here, and we can see the actual web shell code here. In addition to that, we could also say actually go to the URL directly, like so. Go ahead and enter, and go ahead and be like, I don't know, duh, or who am I? And then run basically the same command. So it could then be like, I want move my VMware out of the way. I could then just say I want this command here, like so, copy, go into here, replace this there, and then we'll see the same thing. I missed the C in curl, hit enter, and then we can see the thing here. Then all we want to do is we then want to pipe that into bash, like so, and that should work. We'll go ahead and do this in the terminal though. Go ahead and hit up. Go ahead and do pipe bash. Now, if you look down here, we should get some. We should get a connection made. Watch. Hit enter. Cool. We have a connection. Who am I? I am Matt. Sweet. So, again, like when you get access to a machine or a named user account, the first thing you want to do is figure out, you know, where you are, what you're doing, what kind of machine you're on. So in this case, I'm running as Matt. I want to go ahead and actually just upgrade my shell a little bit, just so I have a slightly prettier experience. Go ahead and enter. Pass that in here. Again, all the commands in my write-up, go ahead and check it out, should be fine. Cool. Now again, we have a usenamer account, so I'm going to go ahead and hit sudo l. Now unfortunately we get an error here saying perm root set res UID operation not permitted. Basically, this isn't saying we don't have sudo, this is saying we don't have access to run sudo, which is not the same thing. So that tells me we're in some kind of restricted environment. Now, there are many ways to break out of it. The easiest one, since it's just very commonly available, is using, let's go ahead and actually just see if it's even on the box. 4000, dash perm 4000, and then pipe the rubbish to dev null. I use AT if it's even on here. It is, yep, so AT. Basically, there's a way to do a shell breakout via AT, AT bins. You can do a shell breakout via that. It's a bit of a weird one, but basically, if you're in like a restricted shell, you can use AT, and because it's SUIDed, it works to basically drop you into a better shell. So if you ever do get put in a restricted shell, you can just run this here, and it will give you a better shell effectively. If we go ahead and say run this now, we should then be given a better shell. If I now do like say sudo -l, it should then work. Okay, it doesn't work because we're not using a proper terminal. That's okay, but it would work if we had a proper terminal. Now, off the back of that, I'm not a massive fan of having this shell that we have right now. What I would prefer to do is I would prefer to escalate this to basically SSH. So we use SSH for Daniel. We can probably use SSH for Matt. Now the process for adding SSH is quite simple, but it does have a few steps. So I'm going to go ahead and do a few things. So we'll go ahead and first of all, go ahead and create an SSH key. So I'm going to go ahead and do SSH keygen. I don't want to overwrite my current one, so I'm just going to call it like, I don't know, HTTP for the moment, and then hit enter, and that will create a file called http.pub. We're not going to be using this one, but just know that I would have created it, and the one I'm going to be using is idrsa.pub. So if I now do get pub key, like this is a command I made, which just prints out my public key, basically, and it makes my life easier. But basically, all we're doing here is we're just echoing my public key to the authorized keys. Now, this file doesn't exist within the mat directory, at least not that I'm aware of. We need to go ahead into cd into mat, like so. cd, yeah, I'm cding into home mat, it doesn't work. We'll just do cd. Cool. Okay, apparently we can't do that either. We'll cd into root, cd into home. If it even lets us, cd into mat, and then we should be in here. Cool. We'll go ahead and do ls-la, and there isn't an SSH directory, so we need to go ahead and make directory .ssh, like so. Hit enter. Now, just as a proof that it's worked, we'll go ahead and do ssh mat @box. It's not going to work, it wants our password. We'll go ahead and just copy this command here, like so. We'll go ahead and paste it in here. Again, all it does is it echoes our SSH key into this file, and then we're just going to go ahead and head it, which will just basically tell us that it worked. Go ahead and hit enter. Quite messy, but that's like duplicates all our commands really. But really, all it's done is just it has just cat .ssh authorized keys, and then you can see there we have our Kali key, which has been put in there. Cool. Now we go ahead and run the same command. And boom, we're in mat. Sweet. So now we have an SSH shell. It has colors, it's fully interactive, and we're in a good spot. And also we bypass having to use that AT thing, because AT thing, as good as it is, isn't super, it's not as good as SSH. SSH will mostly always win, since SSH is just better. You know, it's made for remote administration, whereas a reverse shell kind of is just made as a temporary solution. Okay, cool. So now we're mat. Again, we want to go and do sudo, so sudo -l. We don't have Matt's password, so we can't do that. Okay, cool. So I mentioned before about the skip to go thing with the SUIDs. Let's go ahead and check that out now. But before we go ahead and do that, I want to go ahead and just do my classic enumeration of the environment. So we want to go ahead and basically do enum scripts like linenum, linps, that kind of thing. I'm going to go ahead and cd into my tools directory. So cd, tooling, armory, Linux proof escalation, and in here we have just a few files, /l, just linps and linenum. I'm going to go ahead and do lc web, which will basically just, I'm already using the address, go ahead and just kill it, this one here, run this again. Basically it will just kill the bash file, pass it into bash, pipe the output of that into a file, and also run it in the background. So it basically just does all the work for us. We'll go ahead and copy this. We'll go ahead and cd into temp, which will basically just store it in temp, so it's not like, yeah, so it just has a nice place to sit. Go ahead and hit enter. One request made here, and then we should get a second request made any second. These errors here don't mean anything, it's just basically linenum linps doing its thing. Okay, cool, we have linenum and linps downloaded. We now do like ls-la here, we can see the size of these files slowly increase. this is 1660, 160, this is 55. Go ahead and hit enter. This is increased a little bit, and bits and pieces. So obviously it's kind of writing to it. So we have those in the background to refer to, but I always like to do the manual enumeration first while it's running, rather than waiting, because I think any time wasted is just time lost, really. Okay, so sudo didn't work. Let's go ahead and look at SUID binaries. Now, a SUID binary basically will run as the owner of the file. So, for example, if we go ahead and do find / basically root perm, which is permission -04000, which says all SUID binaries, and then we just pipe any errors because we're going to get like permission denied to all the directories we can't read. That will give us a nice list of all SUID binaries. So all these files here, when executed, they run as a root basically, but because they are put together in such a way, they won't just give you a shell as root. So it's important to find a SUID binary that you can exploit. For example, if there was like, if we go on GTFO bins here and we look at like all of these SUID options, if we have SUID on any of these, like such as base 64, we can then get, say, RCE. We can basically get like a root, or we can at least get SUID. We can then escalate to the SUID user, which in this case, if it's SUID, it's like we want to basically install this, whatever it is. I guess it's prepping it, setting up a local file and the base 64 in it, and then we're decoding it. Don't really know how this works, but basically, I guess what it's actually doing, I guess what it's actually doing is just piping it into base 64 and then decoding it, and then it's running it as that SUID privilege. So I guess that's kind of how it works, but the point basically is that with SUID binaries, if we can make it run, say, a bash shell, or it can make it read a file, it will read it as the owner of the file, and if the owner of the file is root, it will then give us access to root. Let's go ahead and look at, say, sudo. You use sudo probably on the daily. Let's go ahead and look at it, ls-l. Go ahead and hit paste here, and we can see here that it has the S on the user group others area. So this is like owners, this is groups, and this is others basically. So owners, groups, others. So others can read and execute, groups can read and execute, owner can read, write, and it has the SUID bit on it, so therefore when it runs, it will run as the owner. So basically what it means is when we run sudo, we can then run as root, and therefore we can then of course execute commands as root. But obviously if we don't have permission to run commands as sudo, because say sudo has a password on it or something like that, then obviously we can't run it, and therefore we can't get root. But if you go ahead and now look at the SUID binaries, we can go ahead and obviously just kind of look through here. So let's say we grab, I don't know, umount, for example. We'll go ahead and paste this into here, like so. Umount doesn't have any. We'll go ahead and say look at AT. Now AT does have an entry, but it doesn't have a SUID entry. We have a shell, command, and sudo, but we don't have a SUID. If we look at, say, I don't know, date, this does have a SUID. So you can kind of see here that basically the way it works is it's going to, if we have SUID date, we can then get privesc. AT doesn't have a SUID option, and nor does the umount that we looked at before, so we need to try and find another one. The more you do these boxes and the more you work with Linux machines, the more you learn which ones are like normal, expected, like sudo, password, su, at, shush, all those ones. Unless a new vulnerability comes out, it's very unlikely you can actually use them to exploit and privilege escalate. Now, I notice among them we have a Pandora backup. Now, I guess it is a little bit obvious because obviously the box is called Pandora and all this and that. But, you know, sometimes there is a user-created bash file, binary file, whatever, and it's set as a SUID for whatever reason in the real world or in a CTF, and it has vulnerabilities in the way that if you can leverage its vulnerabilities, you can of course then, you know, get RCE, privesc, read a file, write a file, whatever, you know. In this case we have Pandora backup. Now I don't know what this file does, so it's our job now to basically figure out what it does. Now I want to go ahead and run strings on it, like so, and strings will effectively just print out all of the strings in a file. Now, unfortunately, strings isn't installed, so we want to go ahead and basically host a web server to pull it onto our local machine. We'll go ahead and do that now, so python -m Or actually, we need to find out what Python's installed. So we'll do which Python, no response. Which Python 3, we got a response. Cool. So we have Python 3 on the box, fine. Which means you do Python 3-m http.server and then 9000 because I just like that port for web servers, and that's now working. We'll now go ahead and open the terminal just it's easier. We'll go ahead and we'll get $box 9000. Cool. We'll go ahead and we'll get it. Cool. And that doesn't exist right now. Probably because I messed something up, who knows. We did get a request, but Pandora backup doesn't exist. That's because we haven't actually copied it. We need to go ahead and move it into the right directory. We'll go ahead and cd into user bin, like so. Now we can go ahead and run this. Now we can go ahead and run that, and we should then get what we get, and indeed we do. Cool. Now we can go ahead and run strings on Pandora backup. Now what this will do, like I say, is it will literally just look for strings in a file, and it will print it all out. A lot of the stuff won't be helpful, but some of it will be. For example, maybe a password in there, who knows. This stuff is just like libraries, puts, set RUID. So this basically just make sure that you're running as this basically makes sure that you're running as a like UID 0, because it's going to run as root, and it basically says, I want you to maintain this privileges. I want you to maintain root privileges or maintain the EUID, the effective UID set when the binary gets run. Some just jibber jabber here. We have this here, just a basic title, some echo. We're using tar to do something to some file, and that seems to be it. This is quite messy. I prefer to use ltrace, which is very similar to strings in the fact that it will basically just dump out information about the binary. But what it will do in this case is it will actually dump out, it will actually run the binary and look at what libraries were called. We'll go ahead and enter. We're getting an error here because basically Pandora backup isn't executable. Go ahead and run this. Still getting an error, no worries. Chmod plus x. Pandora backup. Hit enter. Now we can go ahead and run it. And then now, you can see here, these are the libraries it's calling. These are the the internal Unix libraries it's calling. So when the command runs, it's running getUID. It's running getUID, set RUID. It's then basically putting just means basically print it out. Put again, printing this out again. Then we have run this command here, so system tar something. And now when I look at this, I see, okay, so this is all fine. Basically maintain privs, so basically maintain root. But I see here we're using tar, then we're doing, basically I think this is like to tar some file and then basically store it in another directory. And the directory is in root, so we're basically just tarring a bunch of files basically. But what I see here is we're using tar and not the path to tar. So if we do like which tar, for example, right now, we get user bin tar, right? But if we look in the binary, we're not using user bin tar, we're using tar. So our system, our Unix box, needs to know where tar is located. And of course, if we have like which, we can ask our Unix box, where is tar? And tar, it tells us that it's in user bin tar. But how does it know that? Well, it knows that based on the fact we have pathing in place. If I go ahead and echo the path, which is basically a list of directories to check when we are calling a binary, we get a list of all the directories. We go ahead and set this, like so. We can actually go ahead and see all the individual lists. So it's going to go ahead and check here, 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 here. And if we look in here, user bin tar aligns with here, so it's going to say, user bin, there's a tar in here. Like we could actually say do like, I don't know, like think of like find, then like the path, and we could then say, I don't know, dash name tar, and then will then give us there. So it's kind of like the same. So like when we're doing which tar, we're then checking the path, which user bin is one of it. It's then going to say, cool, yep, user bin, and we're then going to be doing something like find tar inside user bin, which will then say, yep, it's in here, and then we'll then run tar, and then it will run as you'd expect, like that. Okay, so what does that mean? Well, because the binary is using tar and not user bin tar, we can use what is, I guess you would call like an environment variable attack, path environment variable attack, where basically we can inject our path into the path, as in we can inject our own path into this path variable. So when it reads the list of directories, we can then we can then make it get to our directory first, and it will then find the tar binary in our directory first, and it will then run our tar binary instead. This is the same as, I guess, unquoted service paths in Windows. So again, in Windows, if you say do like a command like I don't know, Notepad, for example, when Windows will check its list of paths, its environment variables, and it'll say, okay, Notepad is stored in C Windows System32 Notepad or wherever it's stored. But if there are spaces in the directory path, then it may then actually check multiple paths at once to be like, oh, is it in C users? Is it in C program space files? Basically, it's just kind of checking all the paths. In this case, we can inject our own path into it, so we can actually say, okay, right, if we go ahead and put our path in here, it will then check it. So let's go ahead and do that. Right? So let's go ahead and run tar first of all, right? And tar gives us, you must specify 1. Now this is the tar binary, right? If we do like tar-help, we get a bunch of output. That's the tar file. Let's go ahead and create our own tar file. I'm going to go ahead and echo just a simple thing of ID to a file called tar, right? Super simple. Chmod it like so. So it's a valid executable. Cool. Now if we now run tar, we're going to get this. If we now run /tar, which says basically the current directory's tar, it's going to run our tar. It's going to tell us that we're running as Kali. Makes sense? So we echoed ID into a file called tar, and when we run ID, it just tells us what we're currently running as. We then set the tar file to be executable. We then run tar without any /, and it runs the tar binary, which is stored in user bin, like which tar. It's running this one. If we do /tar, it runs ID. That's what we specified here. And yeah. So how do we exploit that? Well, we want to go ahead and inject our own path into the path. So if we do echo path, like so, we're going to get a long list of paths. Actually, maybe I'll keep the set in there as well. Right, cool. Now we get all these paths, right? So what we can do is we can then inject our own path in there. So we can then be like, I'll actually keep this here. So we'll do path equals and then the current directory. So we could do like say like this pwd, which will just basically give us the current directory like so. Like that. So if we then were to like basically take current directory, which is this, can be like echo path. We want to be like path equals then basically the current path to our binary like this. We'll go ahead and just quote it so it's all together. :1 like so. You will see here that there isn't a Pandora right now, but if we run this here, there now is a Pandora. And therefore, if we now run tar, whereas before we ran the real tar binary, now we're running the ID tar. Now, if we go ahead and remove this from the path, we would then be presented with it not working. If we go ahead and now make a new terminal, which won't maintain this path here, while we run tar, it should run our old version of tar. But because this here, if we echo the current tar, if we echo the current path has this in here, it's going to check this path first. We go ahead and do the same thing here, like so. We can see that it isn't in there. It's not in the path. But in this one it is. Like so. So, getting back to the main point. So, we create a binary, we store it in the current directory, we override the path, and then we then run the SUID binary. It will then use our path instead of the original path, which would be in previous cases would be user bin. Let's go ahead and try that out. So what we'll go ahead and do now is we'll go into our box. We'll go ahead and just go off here. We'll go ahead and just go into cd temp. We'll go ahead and create new things. We'll call it echo. Now, due to the amount of output you get from the Pandora file, we're going to go ahead and do a touch. So touch will simply just create a file. We'll do touch, and then we'll call it Sakura, right? Or I don't know, sub to Sakura, right? And we'll know basically that if this file exists, we have permission to run a command, right? So currently this file exists. It's called tar, right? If we were to like say run tar, we'd go ahead and just chmod it. If we go ahead and run tar, like so, we now should have a sub Sakura, right? We'll go ahead and ls-la-l tar, not tar, sub Sakura. And you can see it's owned by mat, okay? If we now go ahead and remove subsec aura, and we now go ahead and set the path to be our current path, so path equals /temp colon $path, and then we then echo the path, we'll then see that it's now in here. See, we have temp in there, right? Now, if we type in tar, it's then going to use our version. Now hit ls, we can now see subsec aura. Cool. Now go ahead and ls it, like so, and it's owned by us, which is fine. We're going to go ahead and remove it, like so. Now, if we check here, it isn't in the directory. Now, if we do user bin Pandora backup, go ahead and enter. That's done its thing. Cool. Now we do hit ls, and there we have a subsec aura. Cool. And who owns it? None other than root themselves. See, it's owned by root. Therefore, we can then execute commands as root. So what we want to go ahead and do is we want to go ahead and basically modify none of the file. So tar, we'll go ahead and change it to be something a bit more interesting. So in this case, we'll simply just make it make a file for us. So in this case, I want to go ahead and make it make a root file for us. So simply what this will do is it will copy bash, so bin bash, to our current directory, so temp, and then it's going to chmod it with SUID of the current user. So basically, because this file is going to be ran by root, it's going to basically make our own SUID binary where the owner is root, and therefore when you run the binary, it will then run as root. We'll go ahead and hit enter and hit save. Cool. We'll now go ahead and run this command again, like so, whatever it is. Here, hit enter. Now go ls, and now we have root bash. You can see that it's bright red, which tells us that it is a SUID binary. It's owned by root. The group, we have root bash here, and it has the s here. We now do /root bash. Now this won't work because basically the way that bash works is the bash binary won't preserve the permissions. We do root bash here, we do id, it still says we're mapped, right? It won't preserve the permissions, it will drop down the permissions to the person who runs it. Because bash isn't owned by root, but in this case it's a SUID, but it doesn't maintain the permissions. So we want to go ahead and use a command which is actually luckily inside bash, which basically will preserve the permissions. Very much similar to to what is used in the ltrace, like so. Ltrace. It's basically very similar to setting and getting the UID to be 0. So in this case, basically we run this here, and we will be mapped. We go ahead and exit out, but in this case it wants to let me exit. We'll go ahead and then add in the -p, which means preserve. We can actually go ahead and maybe find that in there. It might tell us. It doesn't tell us actually, but we go ahead and Google and it will tell us. Okay, go ahead and p id, and we are root. We can go ahead and cat root.txt, and then boom, we have root. Let's go ahead and take a quick look at the bash-p command. Maybe it will have it in there. I've actually explained this concept before and actually had issues trying to actually explain it. Maybe this can actually help me. So yeah, so it says turn on whenever the real effective user IDs do not match. Basically, disables the processing of the environment file and importing of a shell. And that doesn't really explain much what it does, but basically what it does is if there's a mismatch of the EUID and the UID, it will then just create an EUID instead. So in this case, you can see when I ran this before, we had a UID of 1000, 1000, 1000. It will create an effective UID of 0. It basically creates as a secondary permission, which gives us an effective UID of 0, which basically means we can then run it as root, and that's how we ran it, if that makes sense. There's also another way we can do it. We can, as my write-up shows, we can also use this method here, where we create basically a C file and we compile it. So here's the service. We compile it. The reason I'm not doing it in this case is because the Unix box doesn't have GCC installed, and sometimes there are issues of compatibility, between like kernels and all that stuff, and it just doesn't work. So in this case, I'm just simply going to ignore it. But there's the information here anyways. But yes, hopefully this all made sense. Hopefully you learned something, and yeah, like, comment, subscribe, and I will see you next one. Take care, everyone. Bye.